I will be presenting to you about EBM melting, specifically with powders. So the process description is it uses metal powers melted layer by layer by an electron beam gun, which is, if you look at the figure to the right, it's at the very top, and it goes through, I believe, three lenses, and then it goes down to the actual bed where the part is made layer by layer. On the left and right is where the powder is stored, and that's actually where the vacuum is at. The electron beam is controlled by electromagnetic coil, so it's very accurate. Some of the process features that affect part quality are powder properties, beam power, the beam speed, and then actual ones that I'll talk about later are the warming process, which frees residual stress in the powders, and the vacuum controlled area, which maintains chemical specifications for the built material. Some of the niche process capabilities, Arcam was talking about their multi-beam technology, which allows for several melting pools. I believe that's simultaneously. So, materials used, the ones that I was looking at are mainly titanium alloys, and then cobalt chrome. And so each one of the titanium alloys has their own, um, I guess, build features. So if you're going to build something smaller, you're going to want to use I believe the first titanium alloy and so on. So I'll talk about it in the part of the next slide. So for the case study, so as some of you may know, I'm on Baja Beaver Racing team. So obviously I'm going to show you a race car gearbox that's manufactured with Arcam's EBM using one of the first titanium's alloys powders. So AM was used because it's a prototype part, so it's cheaper and well, I don't know if it's cheaper, but it's gonna be faster than doing a one-off, and also you're using titanium, so it's good machinability, but heat treatment is still recommended. I guess that's kind of an industry standard. It's a pretty complex part, and I got that straight off of Arcam's website. So. Another part that I thought was really cool was a lattice skull implant manufactured with Arcam's EBM using grade 2 titanium. Grade 2 titanium is corrosion resistant against most applications, so if it's going to go in your skull, I mean, you're not going to want it to do anything crazy. It's high strength to low weight ratio, so it's a pretty good material to use. Um, so So the vendors, obviously, what I've been talking about is Arcam. Their main office is in Sweden. Their website is right there, LinkedIn. They have three main products. Arcam's Q10, which is designed to meet like the implants, like the previous slide I just showed you, and then the Q20 is for more of an aerospace, and also the first case study I showed you with the prototyped um, case. And then Arcam's A2X, which is pictured there on the right, that one's suited for a production environment and R&D. The details of the company, Arcam was founded in 1997. It has support offices located in the United States, Italy, China, and the UK. Arcam's vision is to revolutionize the art of manufacturing complex parts. They've filed over 25 patent families for EBM and is currently has 50 granted patents in various countries. So